In 9.4, we're going to start our discussion about the first trig ratio that we're going to talk about, which is the tangent ratio. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle, okay? And we use these ratios to find the measures of a side or to find one of the acute angles of a right triangle. So first thing we have to kind of think about is the triangle itself. And so we have a right triangle, and we know that this is a leg, this is a leg, and this is the hypotenuse. And so when we're dealing with, first of all, trig ratios only work with right triangles. And when we're talking about them, we're going to refer to one particular angle in that right triangle. And when we don't know the angle measure, we just call it theta. This little symbol here, we call it theta, okay? And so if we're trying to identify or create a trig ratio, when we look at these things, we're going to look at how the sides relate to theta. In other words, this side here, this leg, if you notice, this is opposite. This is an opposite side of theta. It's the side opposite to theta, right? If we notice this one here, this leg, well, this leg we can call adjacent to theta. Okay, so that's an adjacent side. And the hypotenuse is also adjacent to theta. However, it's always just the hypotenuse. So when you're dealing with trig ratios, you're going to deal with sides that we're going to refer to opposite side. You're going to deal with adjacent side. And the third side of the triangle is always going to be the hypotenuse. And like I said, you know, the hypotenuse and the adjacent side, right, are always going to be, both of them are really adjacent to theta. But again, because the hypotenuse is always the hypotenuse, there's only one other side that is adjacent. So the legs are opposite and adjacent, the hypotenuse is the hypotenuse. So how does that apply here? Well, again, here we're looking at the tangent of angle A. And so when we look at angle A here, okay, the tangent is going to be A over B. Well, let's look at this. A is the side opposite, and B is the side adjacent. So what we're learning is that the ratio that we use to find tangent, the tangent of an angle, is going to be written as the opposite leg, the length of the opposite leg over the length of the adjacent leg. So we call it opposite over adjacent. So if we're coming to this problem here and we say express A, the tangent R, as a ratio, well, again, tangent of angle R as a ratio is going to be the opposite. So tangent of angle R is going to be the opposite side, the length of the opposite side over the adjacent side. And in this case, the opposite side is 3, and the adjacent side has a length of 8. And so the tangent of R is going to be the ratio 3 over 8. So that's the answer there. Now, what is the ratio of the tangent of angle S? Well, again, angle S is now going to be, I'm going to look at that a little differently, right? Because again, we know this is the hypotenuse over here. That's always hypotenuse. Angle S, the side opposite angle S, is 8, and the side adjacent is 3. And so 8 over 3 becomes the ratio that we would use. Now again, this is in ratio form. If I wanted it as a decimal, I would do 3 divided by 8 here, and I would get my decimal, and I would round it to 4 places. So I'm just going to do it on my calculator, 3 divided by 8, and I'm going to get 0.375. It actually stops there. And then 8 divided by 3 is going to be 2.6667. I'm going to round it. But again, if they want it as a ratio, they just want it as a fraction. So this and this are not necessary for this problem. So again here, they want to know certain tangents of certain values, and they want to use your calculator to do that. So again, I'm going to make sure that my calculator, right, I got to make sure that calculator is set to degrees. Okay, so you're going to look at the top of your calculator, and you're going to look either for D like that, or you're going to look for it to say DEG somewhere. The alternative is radians with an R or RAD, and we're not working with radians just yet. We will, but not just yet. So the tangent of 45, I'm going to insert that in my calculator, and I'm going to get here is equal to 1. The tangent of 36 degrees is equal to 0.7265. Now you might say, notice that the tangent of a degree is in a decimal form or a number. Well, what if you give you the number and we're asking you for this? What we're asking you for here is what is the degree? Well, in your calculator, when you're looking for tangent, you use the button that just says tangent. But when you're actually looking for the degree, you're going to look for the inverse tangent, and that button looks like that. So again, I'll come to my calculator and I'll say, okay, well, 2.4751 is the tangent ratio. It's the tangent amount for what measure? And when I hit the inverse sign, inverse tangent, I realize that it is the tangent of 68 degrees. And when I go to 0.8098, and I'm looking for degrees, so I do inverse tangent, I notice that I get 39 degrees. And so when you use inverse tangent, to find the acute angle measure, right? And you're going to use tangent to find the, you would say the decimal value of the ratio, okay? So one you're trying to find the decimal value, the other one you're trying to find the degree that created that. So again, how do I use a tangent to complete a triangle? Well, first of all, let's talk about what we mean by complete a triangle. So when we say we want you to complete a triangle, that means we want you to find the measures, okay, of all three angles and all three sides. So one angle is already given to you, right? We know angle C is 90 degrees, but we need to know A and B, and we need to know the third side. The hypotenuse is missing, so our hypotenuse is what's missing here. So let's try to see if we can complete this triangle using this information. First, we're going to do, I know, for example, that angle A, right, the tangent of angle A, whatever angle A is going to be the ratio of the opposite side over the adjacent side. So the tangent of angle A, if I do 2 divided by 7, I'm going to get 0.2857. And if I have that, I'm going to use the inverse tangent function to try to find out, right? So tangent inverse, I'm going to do 0.2857, and that's going to give me the degree measure that goes with it. And I see that that equals 15.9 degrees. So A is 15.9 degrees. Now I'm going to do the same thing for B. So I'm going to say, okay, well, angle B, I know the tangent of angle B is going to be the ratio of the opposite 7 over the adjacent 2. So first of all, I'm going to do 7 divided by 2, and I'm going to get 3.5, and I'm going to now use the inverse tangent to try to tell me what is the degree measure for B then, right? So inverse tangent, and I'm going to get 74.1 degrees. So 74.1. Now, if I did it correctly and I rounded, notice that 74.1 plus 15.9 add up to 90 degrees, and 90 and 90 is 180, which makes sense. So I know my degree measures are accurate here. And so that's it. So again, tangent of A, I meant to write this in here, is 2/7, which equals 0.2857. And tangent of angle B is 7/2, which equals 3.5. And then I do the inverses to find the degree measures. And that's how I use the tangent ratios to allow me to complete this triangle. So again, we're going to do the same thing here, and we're in a similar position. So first of all, notice that I need to do tangent ratios here. I've got angle B. Well, I've got opposite and adjacent, but guess what? I have no opposite. Well, notice that you've been given two sides of a right triangle, and so you can still use something you learned from the beginning. You can use the Pythagorean theorem to find this third side right here, right? I don't know what that is, right? So let's do that. So the first thing I'm going to do is I'm going to do a squared plus b squared equals c squared. I've got 8 squared plus b squared equals 17 squared. 64 plus b squared is 17 squared, which I believe is 289, but let me just double check. Yep. So 289 minus 64, so b squared equals 225, which means b equals 15. So this side here equals 15. So complete the triangle. I've got side AC equals 15. I have side BC equals 8, and side AB or BA equals 17. So I have my three sides. Now I just need my three angles. Well, angle C is easy. It's 90 degrees. It always is, right? Now I need to find angle A. So I'll start here, and I'll do angle A, right? Or I know that I have to set up a ratio here. The tangent of angle A is going to equal opposite side over adjacent side, and opposite over adjacent is going to equal 0.5333 as a decimal. So if I want to know the angle measure, I'm going to find the inverse of 0.5333, which equals 28.07 or 28.1 degrees. So angle A is 28.1 degrees. Now, I can then just subtract that from 90 and find angle B, but I still would rather solve it mathematically and make sure that I didn't make any mistakes. So I'm going to continue to solve this using the math skills. I'm not just going to subtract from 90 and tell you what B is. So here we've got the tangent of angle B is going to be the opposite side, the length, over the adjacent, which is 8. If I do 15 divided by 8, I'm going to get 1.875. And if I do the inverse of 1.875, inverse tangent on my calculator, I'm going to get 61.9 degrees. So 61.9 and 28.1 does add up to 90 degrees, so I know I did this right. So I've got angle B is 61.9 degrees, and angle A is going to be 28.1 degrees, and all three of them add up to 180 degrees, as they should. So again here, I'm doing, again, the same thing, but instead of having to solve the whole triangle, I just have to find one missing value. So notice here in this problem, they're asking me for x. Well, x is the side opposite of the degree or the angle that we currently have. So I know the setup. If I was trying to solve this, I know that I would write the tangent of 24 degrees is equal to the opposite side over the adjacent side. So I'm like, okay, can I use this to solve? Well, yes. In math, right, we can solve anything. We're solving for x. If I want to solve for x, I know that I have to multiply both sides by 20 because that will eliminate my denominator. So now I'll have 20 times the tangent of 24 equals x. So I just come to my calculator, and you don't have to write this out. I'm just going to do it to show you. I'm going to do 24, and the tangent of 24 is 0.4452. And if I multiply that by 20, I'm going to get 8.904 equals x. And it says round to the nearest tenth, and so I'm going to round it to 8.9. So I was able to use my trig ratios and algebra to find the missing value. So this one's kind of interesting because this one here says use special right triangle to find the tangent of a 60-degree angle. Well, first let's write out a special right triangle. We know that this would be a 30, 60, 90. And if we're thinking about that, remember that we talked about these triangles having specific ratios. I don't actually need the side measures, the specific side measures to figure this out. I know the side opposite the 30 would be, let's say, A. The side opposite the 60 is A radical 3, that's this side. And the hypotenuse would be 2A, and that's up here. So if I wanted to use this to find the tangent of 60, let's think about what exactly the tangent is. Remember that tangent of 60 is the opposite side over the adjacent side, right? That's always the tangent of anything. So tangent of 60 is going to be the opposite side. That's A radical 3 is the distance. And the adjacent side is A. And notice that if I just do the math, I'm going to be left with the square root of 3. So the tangent of 60 degrees is the square root of 3, and that would be my answer. So I don't need, legitimately, I don't need to have the actual lengths. I'm able to find the tangent based just using the ratio values that I know exist in this special right triangle. And the last kind of question that we're going to do is going to involve some word problems with regards to angles of elevation and trying to find missing values. And so I think it's a little bit easier when you're thinking of, let's say, a building, right? And there's a building, and then here's the ground, you know, in front of the building, and, you know, somebody's standing here looking up at the top of the building, and you realize, wow, that just kind of created this right triangle. This is kind of like the height, right, or the altitude of the building. Altitude, right? This is like a horizontal length, right? And this is your hypotenuse, really, if you notice, right? And so, you know, this is going to be either your opposite or your adjacent, depending on the angle we're talking about. And this is also going to be your opposite side or your adjacent side, depending on what we're talking about. And so when we're trying to figure out missing pieces, we need some angle measure to help us. And they're either going to give you this angle measure here, which is your angle of elevation, okay? And it's basically from this horizontal line and then the look up at something. So that angle of elevation will be there, okay? And if you happen to be up at the top and you're looking down, they might give you what's called an angle of depression. Well, angle of depression, you have to kind of create this imaginary horizontal line, and your angle of depression is here. So angle of depression would be outside of kind of like the triangle. Just know that your angle of depression and your angle of elevation would kind of be the same, and without getting into too much detail, they would be parallel lines cut by a transversal, and they would be considered alternate interior angles, and that's why they're equal. But again, that's a conversation for another day. So if I was to give you a word problem using these, let's think of how we could apply it. It says you're measuring the height of a tree. So again, you've got the height of the tree here, and it's h. Notice it forms this right angle with the ground. This horizontal length is 45 feet. And somewhere here it tells you you measure the angle of elevation from the ground to the top of the tree. So from here to here, the angle of elevation is 59 degrees. Find the height of the tree to the nearest foot. So they want to know, well, how high is the tree? Well, again, notice that the height of the tree is the opposite side, and you've been given the adjacent side. So you know that tangent of 59 degrees is going to be equal to the opposite side, the length, over the adjacent side, which is 45. So if I'm trying to solve for h, if I simply multiply both sides by 45, I should be able to find this answer. By doing the multiplication, my denominators cancel, and I get 45 times the tangent of 59 degrees is going to equal my height. So when I come over to my calculator, again, I would leave it in my calculator. I would never really write out what the tangent of 59 is, but I'm just doing it for you. Make sure that when you type tangent of 59, you get 1.664, let's say rounded to 43. And then I multiply that to 45, and I'm going to get 74.9 feet is equal to the height. So 74.9. Now it says to the nearest foot, which means then I'm going to do 75 feet. So definitely want to round, right? So approximately 75 feet. Make sure you round it to the correct place value because that matters. And so that's how we would use angles of elevation along with our tangent function to our tangent ratio to identify missing parts.